Welcome to the Ethiopian Construction Channel. We are glad to have you here. Let us learn together. Today, let us understand what an RCC structure is and why it is so important in construction. RCC means reinforced cement concrete. It is a composite material made by combining concrete and steel reinforcement. Concrete is strong in compression, and steel is strong in tension. When these two materials work together, they form a strong and durable structural system used in most modern buildings. RCC stands for reinforced cement concrete. It is one of the most widely used construction systems in the world today. Almost every modern building we see around us, houses, apartments, offices, bridges, and even flyovers, are built using RCC. Now let us understand what it actually means. Reinforced cement concrete is a type of construction in which concrete is strengthened by embedding steel reinforcement bars, commonly known as rebars, inside it. Concrete alone is a very strong material. It can carry heavy loads. It can support the weight of buildings, furniture, vehicles, and people. However, concrete has one major weakness. It is strong in compression but weak in tension. Compression means pushing or squeezing force. For example, when you press a brick from both sides, that is compression. Concrete performs very well under this type of force. But tension means pulling force. Imagine pulling both ends of a material. Concrete cannot resist pulling forces very well. It tends to crack when subjected to tension. In buildings, structural members like beams and slabs experience both compression and tension forces at the same time. The upper portion may be under compression, while the lower portion may be under tension. If we use only plain concrete, it may crack and fail due to tension forces. This is where reinforcement becomes necessary. Steel is a material that is very strong in tension. It can resist pulling forces without breaking easily. It is also strong in compression. Another advantage of steel is that it bonds very well with concrete. So, when steel reinforcement bars are placed inside concrete and the concrete is poured around them, both materials work together as a single unit. The concrete handles the compression forces and the steel handles the tension forces. This combination creates a very strong and durable structural material called reinforced cement concrete. One more important reason steel works well with concrete is that both materials expand and contract at almost the same rate when temperature changes. Because of this similar thermal expansion, cracks are minimized and the bond between steel and concrete remains strong. In RCC construction, steel bars are carefully placed in specific positions according to structural design. For example, in beams, steel bars are usually placed at the bottom where tension occurs. In slabs, steel is placed in both directions to handle bending stresses. After placing the steel bars, concrete is poured into the formwork and allowed to harden. As the concrete sets and gains strength, it tightly grips the steel bars inside it. This grip is called bond strength. Once hardened, RCC becomes a composite material. It behaves as one solid structural member instead of two separate materials. Because of this combined action, RCC structures are strong, durable, fire-resistant, economical, and capable of carrying heavy loads. RCC structures also have a long service life. With proper design and maintenance, they can last for many decades. In summary, RCC means reinforced cement concrete. It is a construction system in which concrete is strengthened by embedding steel reinforcement bars inside it. Concrete is strong in compression but weak in tension. Steel is strong in tension. When these two materials are combined, they complement each other's weaknesses and create a material that is strong, stable, and reliable. That is why RCC is one of the most important and widely used construction systems in modern engineering. Main components of RCC structure. Today, we are going to understand the main components of an RCC structure in detail. Let us understand each main component one by one. Cement is the most important binding material in RCC. It is a fine gray powder that acts like glue. When mixed with water, it forms a paste that binds sand and aggregates together. This process is called hydration. During hydration, cement reacts chemically with water and hardens over time. The strength of concrete mainly depends on the quality and grade of cement used. Ordinary Portland cement, commonly known as OPC, is widely used in RCC construction. Cement provides binding strength, initial setting and hardening, durability. Without cement, concrete cannot be formed. Fine aggregate sand. Fine aggregate means sand. It fills the small gaps between coarse aggregates and improves the density of concrete. Sand improves workability, strength, surface finish. Good quality sand should be clean and free from clay, dust, and organic materials. Usually, river sand or manufactured sand is used in RCC work. If too much sand is used, the concrete may lose strength. If too little sand is used, the mixture becomes harsh and difficult to work with, so proper proportion is very important. Coarse aggregate. Coarse aggregate consists of crushed stones or gravel. These aggregates provide bulk and strength to concrete. In fact, aggregates occupy about 60 to 70% of the total volume of concrete. They help in increasing compressive strength, reducing shrinkage, reducing cost because cement is expensive. The size of coarse aggregate usually ranges from 10 millimeters to 20 millimeters in building construction. Good aggregate should be hard, strong, durable, free from impurities. Water. Water plays a very important role in RCC. It starts the chemical reaction with cement called hydration. Without water, cement cannot bind the materials together. But the quantity of water must be controlled carefully. If too much water is added, concrete becomes weak. Strength reduces, cracks may develop. If too little water is added, concrete becomes difficult to mix. Proper compaction is not possible. The ratio of water to cement is called the water-cement ratio. This ratio directly affects the strength and durability of concrete. Clean and potable water is generally recommended for RCC work. Steel reinforcement. Steel reinforcement is the most important component that makes concrete reinforced. Concrete is very strong in compression, but weak in tension. When a load is applied to a beam or slab, tension develops in the lower part. To resist this tension force, steel bars are placed inside concrete. Steel reinforcement provides tensile strength, ductility, crack control, earthquake resistance. There are different types of reinforcement bars: mild steel bars, deformed bars, TMT bars, thermomechanically treated bars. TMT bars are commonly used today because they have high strength and better bonding with concrete. Steel bars are placed in specific positions according to structural design before concrete is poured. Proper spacing and cover thickness are very important to protect steel from corrosion. In conclusion, the main components of RCC structure include cement, sand, coarse aggregate, water, and steel reinforcement. Each material has a specific role, and their proper proportion and placement ensure the safety and stability of buildings. That is why RCC is one of the most widely used construction systems in the world today. Thank you for watching. We hope you found this video helpful and informative. If you enjoyed the content, like the video, share it with others. Subscribe to our channel for more professional construction content.